Hello and welcome to another That's Just Wild Q&A, where we take on your burning questions about nature and wildlife. I'm Steve Backshall, and as always, I'm joined by...
me, Lizzie Daly. And me, Sarah Roberts.
For ad-free listening, our newsletter, special deep dive episodes and members-only benefits, you can subscribe to us at that'sjustwild.com.
Right, the first question for you, Steve, today is from Will on email. Can you train venom cells so that they target cancer cells only and not normal cells in the body?
This is one of the biggest and most exciting questions in pharmacology, and it's one that could have so many implications for cancer treatment. And venom appears to be something that could be absolutely perfect for targeting cancer cells. In actual fact, quite a bit of my academic research was focused on just this. So I had gathered a novel venom. I've talked about that before, so I won't go into that too much. But then the process was that we took this venom in a variety of different dilutions, from absolute neat venom right down to super, super diluted. And we subjected all kinds of different cells to the venom to see what it did. It turned out to have antimicrobial properties, antibacterial properties. But the most exciting is the fact that it absolutely kills cancer cells, and it kills them stone dead. The problem is that it kills everything else as well. And so this idea that venoms could be the panacea, the cure-all for so many different diseases, particularly cancer, has problems because, you know, they've evolved to have so many different effects in the animal that they are preying on. And so it's really difficult. It's really difficult to, as you say, train a venom to solely focus on a cancer cell. Now, I was doing my research with Steve Trim and Dr. Carol Trim at Canterbury Christ Church University. Steve now runs an organisation called Ventera Bio, and this is exactly what they're focused on doing. So I thought I'd let Steve explain in his own words what's possible now and could be in the future.
Hey Steve, it's Steve Trim here from Ventera Bio. Thanks for the great question about can we target cancer cells by training venom cells. It's a very interesting question. When we talk about training cells to target cancer, what we're talking about is the CAR T cells. So these are actually genetically reprogrammed. So it's not training like you would do in an animal sense. But the important thing here is that these are T cells from the body's immune system, and they wander the body all the time looking out for foreign proteins and foreign cells to attack. What we're doing with training CAR T cells, like genetic reprogramming, is alerting them to what a cancer cell looks like and showing the body that it's not a normal cell to go and attack it. The important thing here when we go on to talk about venom cells, which I have to assume you mean venom gland cells, the cells that produce the venom, is they don't wander the body. They are in the gland like salivary cells. They've evolved to sit there and produce hundreds to even thousands of different toxins and proteins to actually then power the venom to attack predators and kill prey. Having said that, that venom can be useful, but I'll get onto that into a moment. So the venom gland cells, because they don't wander around, they're not going to go and attack things. It's not in their genetic nature, and it's not something we can alert and do. But also, those cells produce, say, hundreds and thousands of different toxins, and each of those toxins do different things, have different jobs. In nature, nothing has evolved to help humans in therapy, but that doesn't mean there isn't any crossover. And so some of the receptors that are involved in cancer processing are also involved in predator and prey capture, just through the chain of evolution. And that's why some venoms are actually useful in cancer research. So if we get onto the venom itself, because we can't train the cells because they don't wander around, the venom itself has a very complex mixture of peptides and proteins. And some of these target receptors are important in cancer. And we've done some work with Canterbury Christ Church University looking at cobra cytotoxins and how they can actually be selectively toxic to particular cancer cells. And this is work that we were doing with Dr. Carol Trim several years ago. It's in the process of being published. Also, the most famous of the cancer toxins is chlorotoxin. So this comes from the deathstalker scorpion, Lirius quinquestriatus, and this is a small peptide that targets chloride ion channels that actually are specific in humans to gliomas in particular. And when you then put a dye on that protein, you can actually light up the tumour for the surgeon to see it under infrared light, and then reduce the amount of collateral damage in brain surgery, which also improves the patient's recovery and reduces the mental processing parts that they lose. As an interesting anecdote to that toxin, there's a great series on the BBC called Pain, Pus and Poisons, which we were involved in the poison side of things with the wonderful Dr. Michael Mosley. I got to help Michael in the green room, as it were, actually help him pronounce Lirius quinquestriatus. And then when we went on to the show, what you can see is a deathstalker scorpion walking over x-rays of people with malignant gliomas. And so you could see how the scorpion's toxin could help them in that surgery removed. And I think it's probably on YouTube, and it does turn up on the BBC iPlayer from time to time, so that would be a good one to check out to see how venom can target cancer cells. Yeah, thanks for the great question, and happy to help. Cheers, bye.
So there you go, super exciting stuff. It kind of seems like science fiction, but it is a way that venomous, poisonous, toxic creatures could be of huge benefit to human health.
Yeah, I just love that idea, the chlorotoxin from scorpions literally then being able to light up tumours. It's just, I find that absolutely so extraordinary. So how far off are we, Steve, do you think, from this actually being used more widely?
So there are already a huge array of different drugs that are on the market that come from venoms and poisons. Getting one that specifically functions on cancer is quite a way off. And I did my first story on it way back when I was working at National Geographic in about 2001 with Australian Institute of Marine Science in Queensland. And they'd already gathered all of these organisms that had venoms that absolutely targeted cancer cells, but still haven't, 20 years further on, managed to find that one that can target only cancer cells. But when it happens, it's going to be tremendously exciting. And there's so much work and effort going into this area of study that it could happen.
Love it.
Now, for you, Sarah, from Anastasis, what is the nature of homosexuality, bisexuality in the animal kingdom? And what are the ecological implications associated with it? Does it offer certain benefits not present in heterosexual individuals?
Good question.
Okay, I'm going to dive really, as far as I can dive into this in a very short period of time. So homosexuality and bisexuality is well documented outside of the human species. So around 1,500 species, from insects to mammals to marine life, all partake in various sexualities. For example, penguins. So same-sex pairs have been documented in zoos and in the wild. And the advantage of that is that they're also able to help rear chicks. So they build nests together, they adopt abandoned eggs together, and they do raise little penguins together. And that's in the wild and in zoos, and it's fairly well documented around the world. There is one species, though, that I probably want to focus on more than any others, and that is the bonobos, the very, very sexually active, fruity bonobo primates, which they use sex for many, many things. So let's break it down. So sex plays a part in many different animal groups, from pair bonding to mountain courtship, long-term social bonding. But for bonobos particularly, sex is quite a casual thing. And it's throughout the groups that they live in, practice very, very regularly. So that can be 2 males, 2 females, whole groups. It is part of their group dynamic, and there's a kind of a theory that it's used to, in simplistic terms, reduce hunger. They have sex before they eat. That's what I'm trying to say. I'm really dancing around the subject, but they'll generally be presented with food, or one of them will find food in the wild or in captivity, and then they'll all have a big orgy. And then when they've released some tension, then they'll go and eat. And it actually is thought that that means that they're able to share food and have less conflict than other primate species.
And it's important to reference there that they are, social species. So, of course, there's the act of sex, but it's also to do with reducing aggression, to do with strengthening those bonds. And yeah, I think that's kind of a big part of kind of that sexual behaviour. But it's funny how it's kind of seen. It's not that funny, actually. It's seen widely across the animal kingdom. There's that famous story of the two albatross, two females that kind of bonded. And there's other species as well, like flamingos and like the bonobos that you say. So it's not uncommon in the natural world.
I think that it's quite important that we recognise that sex has other purposes than reproduction, that it can be both for us as human beings and for other animals too, as a source of pleasure, of bonding, of dominance. You quite often see it in things like baboons, where the dominant male baboon will mount subordinates as an expression of his power. And there are so many different other ways that sex happens, and it doesn't have to be just for passing on your genes. And so, back to the kind of the question, the ecological implications, well, there's lots and lots of reasons why animals have sex. And quite a lot of the time, I think it is that they're just enjoying it. I mean, there's quite a lot of times, I have had baboons having sex behind me while I've been trying to do pieces to camera, frankly, wrecking my gravitas. And, they're pretty much just whirling around a cowboy hat in the air while they're going for it like, woohoo! And, there's no reason why we should be the only animal that enjoys sex, is there?
No.
Well, on that note, maybe we should go to our next question anyway. So our next question is for you, Lizzie, and it's from Natalie. And it is, out of all of the places you have been in the world, what climate or landscape did you find the most difficult to have sex? I'm only joking. What climate or landscape did you find the most difficult to survive in whilst out filming and researching?
I'm at a crossroads now. What one do I answer, Sarah? It's an interesting one, because I think my initial instinct is to go the cold, but that isn't going to be my final answer. And simply because, places like high up in the Arctic, where you've got those freezing winds combined with just utter bitterly cold conditions, wind chills of like -50, they are standout moments when out in the field. But I would say the most challenging, both physically, technically, and biologically, is probably in a rainforest. Would you guys agree?
Yeah, 100%.
Yeah. It's got to be. It's the combination of like thick undergrowth and trying to navigate this impossible landscape of trees and vines, and it's just this almost impossible environment to move through. Then you've got kit that just fails all the time because of humidity and moisture in the air. Then you constantly feel totally unfit. I generally think I'm quite a fit person, but the minute I get into any kind of real rainforest environment, I'm humbled beyond. Meanwhile, and it's the Amazon expedition that I did that really stands out for me, because there was a number of mysterious stings, bites, kind of welts on my head and injuries. It just would pop out of nowhere, on top of mosquitoes and on top of, too much information, but the fact that we had only eaten eggs, plantain and rice for about a week. So there you go.
I would say bang on for me on the fact that the rainforest, it's actually down to what it does to the kit.
Yeah.
So when you're working there and you're trying to film, and that's the reason you're there, and every single bit of electrical equipment just goes down. You've got moisture, you've got humidity, you go from being cool at night and damp to being suddenly scorching hot, and all your lenses steam up, and it's just an absolute horror show.
Yeah.
Whereas if you're working in the cold, as long as you can keep your batteries warm, everything works and works fine. Same with altitude. So yeah, there's no comparison. The flip side of that is, for me, doing my job, I would find that if I'm up in the Arctic or in the Himalayas and I'm looking for a snow leopard or looking for a polar bear and I don't find it, I'm stuffed.
Yeah.
Whereas in the rainforest, if I don't find the harpy eagle, anaconda, jaguar that I'm looking for, I know I can turn over a log and there's going to be something interesting there that I can make my television program about.
Yes.
So there's a trade-off there. But at the same time, you get the rainforest during a really steamy, wet, humid time, and it's near enough impossible. You can find something absolutely awesome and you can't film anything other than your phone.
Yeah, it was very humbling. And actually, there's one particular moment that stood out to me when the crew and the locals were just ahead of me. And these locals that just live in kind of a local community just outside of where we were kind of starting our expedition, they're absolute beasts in these environments. They move through it like a gazelle, whereas I'm just like, I'm just so clumsy and so inexperienced in that kind of environment. And so at one point, I actually was behind everyone and they had gone really far ahead and I lost them for just a moment. I couldn't hear a thing other than the sound of the rainforest around me. And it was a moment where, you know, they were just right in front of me minutes ago and then gone. And I thought I would have absolutely no idea where to go, what to do right now if I had to make that decision myself. So it's a very humbling environment.
So yeah, I would add to that. I've had a similar experience underwater with bad currents, with that moment where you're like, I don't know where everyone is. And it's, well, I won't go too far into it, but I would say in terms of surviving on a very, very short term, when you dive in and you've got your air and you're thinking, oh God, I'm going to have to end this, but I'm going to come up and I'm not sure where the boat is, or if I'm going to be anywhere near anyone, or if I can find anyone, then that one, for me, survival's kind of scary as well on that.
Sarah, who's your dive buddy? You need to get more dive buddies.
You know, we do need to have words with Sharkman Dan, don't we, one of these days?
Throw under the bus, no hesitation. Oh, anyway, right, final question, Steve. What is the biggest insect you've encountered? From Zoe K. I'd love to add to that, Steve, in the wild. I'd imagine you'd pick for the wild anyway, but go for it.
Yeah, so I've been ticking off the biggest insect in pretty much every category over the last, whatever it's been, 27 years. So the Queen Alexandra's birdwing, which is the biggest butterfly, we filmed in New Guinea. It's absolutely huge. It's like a big flapping dictionary. The Atlas moth, which is the biggest moth, pretty much the same sort of size, but absolutely enormous. Looks like it shouldn't be able to fly. Wallace's bee, the biggest kind of bee, we filmed in Borneo. I think the giant Asian hornet and the tarantula hawk wasp, which are the biggest of the wasps and the bees. The biggest overall insects fall into two categories, one of which is the biggest and heaviest, and that is Titanus giganteus, astounding scientific name, the giant titan of beetles. It's a longhorn beetle, which is it's getting on for about like 6.5, 7 inches in length, so sort of 20 centimeters. They are enormous, absolutely gigantic, with huge, great big mandibles they use for protection and long horns, antennae that sweep down behind their bodies. The most remarkable thing about finding them at all is that they live almost all of their lives as a maggot, a larvae inside wood pulp, munching away at it, and the larvae looks like the biggest banana you could ever imagine. It's absolutely grotesque. But then it transforms into this winged adult, although I think the males have wings, but the females don't, for no more than a couple of weeks of its entire life. And yet we filmed them on several occasions. And if one flies into your camp, as they do because they're attracted to light, they bounce around the light bulbs and they will sometimes break them because they are that big.
Wow.
They're absolutely overwhelming. They are probably right at the limit of what is possible now here today, with the way that invertebrates take oxygen into their bodies. We probably can't have insects that are radically bigger than that now. We may have been able to have back in the Carboniferous when there was a higher amount of oxygen in the air. There is one added element to this, which is the longest, by far the longest kinds of insect are stick insects. And I thought, right up until this moment, that I had seen the longest stick insect in the world, Farnacia kirby, which is from Borneo, which we filmed many, many years ago. And I had that as my big tick for the longest stick insect in the world. It's almost as long as your arm. This thing is gigantic, very, very thin and stick-like, but enormous. And as we've been talking, I've looked this up online, And it's not the biggest anymore. Someone's found a bigger one in China.
Oh,
and
no.
Which is in the same group, but it's Kinensis, because it was discovered in China.
Oh, Steve.
And so I haven't seen the biggest, longest stick insect in the world. I'm going to have to book myself a blooming flight to China. But yeah, this is the new record holder, which has a total length of 63 centimetres. 63 centimetres.
Jesus.
That's
That is
just
incredible.
Unbelievable for an insect. I mean, that's pretty much as long. I mean, I've got stumpy legs, but pretty much as long as my stumpy little legs.
So, question, Steve, on that. Would the stick insects also have been much bigger, millions of years ago when we did have the dragonflies that were flying around like mini helicopters?
So those super, super long dragonflies, sometimes known as griffin flies, were orders of magnitude bigger than we have them today. So they would have had a wingspan that would have been getting on for about that same sort of length, 60, 70 centimetres. The stick insects are not as well represented. So back in the Carboniferous, we knew that we had bees, ants, wasps. The earliest stick insects or phasmids that we are aware of were more like 126, 130 million years ago. The Carboniferous, 330 million years ago. They may have been around then, but if they were, then we haven't yet found evidence in the fossil record. And to be honest, back then from the Carboniferous, there are still loads of insect groups that we don't know if they were around at all back then. The dragonflies obviously were doing fantastically well. We had the myriapods were there as well. There were almost certainly insects from lots of those other groups, probably the mantids as well. We just haven't found them yet at their greatest size. But because, as you said, the oxygen levels in the atmosphere were 30% plus, and today, they're 21, insects across the board would have been bigger. So yes, there is certainly out there to find somewhere a super giant insect from the Carboniferous that we haven't yet discovered. And when we do, it is going to be magnificent.
I love that. What I'd do to go back just for a day, just get slapped in the face by a 63 centimetre long dragonfly. Right, well, that's it for this week. Brilliant questions as always. Please continue to send them along to questions@that'sjustwild.com and we'll answer them on the show.
Now, we're a new show, so any support's really welcome. You can follow us using your favourite podcast app. Leave us a review. It makes all the difference for the team.
And for ad-free listening, our newsletter, special deep dive episodes and members-only benefits, you can subscribe to us at that'sjustwild.com. Remember, we're on YouTube, TikTok, Instagram, Facebook, and you can find us at That's Just Wild Pod. Thanks for listening. See you next week.